Hello learners. Welcome to GeekLurn.
Class 1. Introduction to Data Science.
This is from our Independence Day, speech by Jawaharlal Nehru in 1947. Okay, but what happens is this is not from him directly. Of course, he did not come up with this thing. It is an ancient Chinese proverb that he had used as part of a tryst with that destiny speech that he gave on the eve of independence. Okay, so always remember what your data source is. Always dig down and go back to the original source of the data. That is the first part of being a data scientist. Okay, I'm assuming that all of you have uh, an ambition to become a data scientist someday. So that will be the angle at which I would be teaching everything. So everything that you need to be a data scientist, you need to understand what are all the various functions within data science. What are all the tasks that you might be able to ask to do within data science? Would you have the skills? Would you have to ramp up your skills? All of those things would be covering on this. So today we're just generally going to look at what data science is, what to expect, some kind of expectation setting, what the course would be like, and all of those things. Let's start off. Sorry. So why is it called data science? What was it called before? Okay. So if you have been around 2006 or something, it was simply called business analytics or analytics. Anybody who was doing what we call data science today would have been called that he or she was working in analytics, business analytics. Everybody was an analyst. Then people started calling it business intelligence because they wanted to make a difference between what people are working on metrics. Okay, so analytics was basically nothing but getting some kind of mathematical illustration of your data. So basically bringing out your metrics. Okay, so analytics was nothing but how much is my revenue, how much is my revenue per region, how much is my net profit per region, what is the attrition rate. All of those are our business metrics. Everything that we do would be in terms of business metrics. Okay? So every business has metrics that are important to them. If you are in retail, inventory would be a very important metric. Okay? If you are in finance, some kind of profitability would be your main metric. And it also depends upon the team that you are on. So for your team, there will be very specific metrics, whether your sales, your marketing, all of those things will matter because there will be very specific metrics that are important for the performance of the measure of performance of your team. Okay, then as things started getting more and more complex, they invented business intelligence. Any ideas what business intelligence is about? It is still about metrics, right? What was business intelligence about? Business intelligence teams still are available in every company. What do they do? So BI teams basically are doing dashboarding. Okay, so dashboarding is nothing but taking all of your information, the metrics which are getting calculated in a real-time sense, and putting them up in such a way that you get to see a whole bunch of your metrics in a visual format. So this is all about data visualization. Okay, so business intelligence teams are constantly working on how to make this data available to the various stakeholders within the team. So for example, if you're a CEO, you need a higher level breakdown of data. If you are a business, if you are an individual contributor or somebody like that, you need a different view of the data. There are different metrics that will be more important to you. So the BI teams make sure that any data is available in a visual format to you in a real-time sense. Then also people started talking about BPO, KPO. Okay, so all of these processes, they are nothing but these are back-end work where all of your data is getting collated and organized, and some kind of intelligence is coming out of it. Then around 2010, this is the time when I started my career in data sciences. By that time, I had worked in few fields before. They started calling it decision sciences because we went from simply showing what is, and we were being asked what could be, what will be. Okay, so predictive analytics started kind of coming in. Okay, and more and more companies were including decision sciences, which is the predictive modeling part. It is not that decision sciences is new. The mathematics and the statistics that were involved go back hundreds of years. Just that your computers became much faster and all of those things, and hence decision sciences started becoming a core component of these things. So you did not need big consulting firms anymore. People could start doing it in house. Okay, people with regular engineering degrees and some amount of work experience could start applying themselves over here. Then, of course, there is the consulting. The consulting field has always been there. Consulting started using predictive analytics like anything because they had to add more to your offerings than what companies were doing for themselves within decision sciences. Before that, consulting firms were basically doing these things and they were charging a big amount. That is where your predictive analytics part comes in. The moment people started using predictive analytics as a key tool, things started going really, really fast because at that point of time, your computing power also started increasing. Your application started getting much faster. Things got extremely simpler. All of these things started happening in predictive analytics. And at a point, people even started coining this term called prescriptive analytics. As in, we're not just going to say what will be the future. We will tell you what the future has to be. So, for example, there was this model that some of the online air ticketing websites started doing. They started predicting exactly at what price people would be willing to buy. Okay, so they did a lot of tests and they started saying that this is prescriptive analytics. We're not in the era of predictive analytics anymore. However, this term did not stand for long, and eventually, we started sticking to predictive analytics. We started using data science. This is where the final thing data science comes in. However, data science is just a little more different from all of these little values. Okay? So these are your traditional business intelligence. These are your traditional data analysis and traditional, analytics forms of work that was happening in your companies. Data science, as on today, encompasses a whole lot of new things. Okay, so this is about 10 to 15% of what is happening in data science today. So let's see what else is out. Before that, let's understand the term science. Where does the term science come in? So typically, when we talk about science, it is broken up into two parts. One is your natural sciences, which describe, predict, and understand natural phenomena. Natural phenomena is anything that is related to our world, the real world. Then social sciences, the study of societies, relationships, and individuals. This also is known as transactional analysis. If you Google this word, right, transactional analysis, you might come across a whole range of topics, basically which form your human resources types of things. Psychology, understanding of how two people behave together. How do you understand if a relationship is trusting or not? All of those things are part of your social sciences. How do economies behave with each other? What are the dynamics of supply and demand? All of these things fall under your transactional analysis. Okay, and people have been using these things in order to understand the metrics of the business better and better. Okay, so under natural sciences, of course, we know that there is physics and chemistry and biology, and all of your applied sciences, your engineering and medicine. Okay, physics, chemistry, and biology are your actual sciences, while engineering is the application of physics or chemistry. Okay, understand the difference. In physics, you would be thinking about things very, very theoretically. Engineering is the place where you take that thinking and you would be applying it. You would be making things. You would be creating technologies. Same with medicine. Just because you understand biology doesn't mean that you get medicine. You have to take that understanding of biology and kind of apply it into medicine. So all of these places require substantial amount of mathematical thinking. How to convert the existing knowledge and convert them into something that can apply. In social sciences, we have economics, history, geography, archaeology, anthropology. There are like hundreds of subjects over here. Even language, understanding of language, how languages evolve, how languages are structured. How can we make a computer understand natural language? The way we talk to your Google, OK Google, and your Siri and your Alexa, right? There is technology behind it which is trying to understand human language, the way we use language. We're not just giving instructions to a computer. We're not saying, Alexa, switch on or something like that, right? We are talking in our natural language, and that is being decoded into whatever the computer understands. So now tell me, where is mathematics on this list? Why are we not seeing mathematics in this list? Is it not a science? Any opinions on that? We know that these are your natural sciences. We know that these are our social sciences. And we know that there is a lot of mathematical application in all these things. Without for talking numbers, we cannot really talk about any of these subjects. Where is mathematics? So mathematics is a language. It is the language in which we speak anything else. Logic happens to be one of the aspects of the language for which mathematics was designed or invented, or it exists. So while a lot of languages have different functions, right? So for example, you have Latin and Sanskrit, the so-called different languages. They have a particular application. They are for explaining what really happened in the ancient times. Okay, they have a particular classness to it. There is some poetry to it, and all of those things. The artistic methodology. So every language has a particular approach and a way it works. Having said that, mathematics' approach is lack of ambiguity. Whenever you're describing something mathematically, the idea is that you should completely eliminate any kind of ambiguity that is inherent to a particular thing. Okay? So if you say something in English, there is a chance people might interpret it in a particular way. However, if you write it in mathematics, there should not be any scope for misinterpretation. That is the main aim of mathematics, and that is why mathematics is an overarching piece of knowledge, which kind of is the base for all of these things. So today I want you to do one particular exercise. Okay, go on any random Wikipedia page and start clicking the very first link that is available. Okay, just start clicking the first link and the first link in the subsequent page, first link in the subsequent page, and see what is going to be the final thing. And if you're kind of stuck in a loop, click the second link. Only then you click the second link. Do this and tell me tomorrow what exactly you found out, and give me some kind of thinking about why that is happening, because that will kind of put a lot of things into perspective for you. Requirements to call something science. So at this point, we have to kind of say, if we are going to study data science, what are the requirements to call something a science, right? So a science is something that builds and organizes the existing knowledge and know-how. Does physics do it? Does economics do it? Does history do it? Geography do it? Does it? These are the things that you need to kind of think about. Is the existing subject building and organizing the existing knowledge and the know-how? Anybody who is working in that field, do they know where they stand? Do they know where to go and get the information? Okay. Then it creates repeatable, reproducible methods to understand underlying phenomena. Is there a way, is there an agreed upon methodology which you have to follow in order to get some kind of an output, which will be acceptable by other people in your business, in your domain? If you are a historian, you are going to write a book and put it out. Will people go back and see the methodology that you have taken and say, okay, this book is good enough, it can be published? Or if somebody, for example, like you and me, start writing something about history, we would know the first thing to approach. We would write down a lot of things that would be our own biases, may not be historically accurate, taken from here and there, not verified, right? However, if you are a trained historian, you would know the regular process in order to put out a book, which will contain all of the required references. It will contain a proper methodology. It will show the debate between existing debates between two particular topics, all of those things. Then does it use mathematics as the universal language to build frameworks and predictive models? Okay. Whether you're a historian or a physicist, you still have to use mathematics. You have to say what was the what was the what was the data set upon which you have built whatever opinion you have. You have to make that available to people so that they also come to the same conclusion as you do. Okay, so are you using mathematics as a universal language? And when you make any prediction, for example, if you're making a prediction in clinical trials whether this drug is effective or not, this prediction must be testable. If I take your prediction and kind of apply to something, if I say something like what the rainfall is going to be so much, there is going to be a cyclone or something like this, that prediction must be testable. And we're not saying that the prediction must be 100% true. We are okay with some amount of randomness. And everybody understands that you cannot predict anything 100% of the time. But is your prediction better than completely random guessing? If there is some kind of a prediction like that, then your prediction is useful and it is fundable. That is the main thing. Okay. And then, is there a variation in the predictions? The variation of the predictions must be within acceptable parameter. Just because I'm saying that I'm okay with some randomness does not mean that you can give me wild estimates. Okay? The predictions must be within acceptable parameters. And those acceptable parameters are kind of written in stone as far as sciences are concerned. And then also you have certain aspects of science that are accepted without debate. So not everything is debated in any subject. Okay, there are certain things that everybody kind of agrees upon. There is no debate that the British ruled India. Everybody accepts that. But what were the conditions upon which this rule happened? That can be a source of debate. It depends upon where your philosophy is coming from, what kind of material you are working from. Okay, nobody has a debate that the planet is round or anything. Okay, especially in science, we do not have that debate. However, there is a debate about what really happened in the earlier parts of the formation of the planet. There could be a debate over there. Only when you come to the fringes of your science, the debate actually exists. Otherwise, a lot of things are kind of accepted because they have been proven beyond a reasonable doubt. When things are proven beyond a reasonable doubt, they become part of your scientific book of knowledge. Now just check if data science satisfies these rules. There is a relatively standard approach to record, store, organize, retrieve, and analyze data. In fact, there are conferences that happen worldwide on a regular basis to share your knowledge, share your best practices upon how you have to record your data, how you have to store your data. There are standards, because if I have to transfer my data to another company, they should know exactly what documents to go through. If there is a merger that is happening between two companies, it cannot fall down because those two companies have incompatible formats of data. There should be applications which should be able to put their transactional data together with relative ease. Sure, the couple of teams would be working on it, but they should have a standardized approach about how to record, store, and organize the data. At the same time, you should be able to retrieve that data at a moment's notice in order to analyze it. Okay, so there is a standard approach as far as the book of knowledge part is concerned. Data preparation, data cleaning, model building, model testing, operationalizing, everything follows something known as an analytics life cycle. So you have a repeatable, reproducible format in which you do any data science project. So it doesn't mean that every time you get a data science project, you're completely figuring out everything from scratch. It doesn't happen that way. There are very clear milestones, very clear tasks that you have to do in order to come there. Sure, at any given point of time, there is some amount of thinking that you have to do, because this is not construction work, right? It is a little high up there. It is not completely cut and dry. You have to do some amount of thinking, you have to ask some questions, but your milestones are very clearly given out. Okay? And the tasks that are expected of you are very, very clear at every given point of time. Unless you are completely a maverick kind of a person, you will follow this thing, and this is what is known as an analytics life cycle. We'll discuss that in a couple of minutes now. So there is a repeatable, reproducible process within data science. Then mathematics and statistics are the core of the subject. You cannot do anything in data science without mathematics and statistics. Everything is mathematical. In fact, the core of data science goes back to your linear algebra and calculus. Okay, we'll have a lot of discussion about what linear algebra is and what calculus is. Almost everything that is built for data science has been built upon the linear algebra and calculus fundamentals. Metrics to measure and test predictions are precise and standardized. Okay. The moment you talk about the ways how you can predict things, the metrics are very clear. We have something known as a p-value. We have something known as test statistics. All of these things can be measured against to tell how good your prediction is. Debates are extremely low in data science because the moment you show that a particular model is working, it is working. I know how to measure the efficacy of a particular model. I can talk about accuracy, I can talk about recall, I can talk about an F1 score. These are the numbers that are already available to the person who is trying to debate you. So debates become extremely low because you already know whether or not your model is worth predicting. If it is not, there is no debate because you're not going to go to the public with it. If the accuracy scores are low, you're not going to publish it. Once you published it, the numbers are already there. Okay, so that way data science is as much close to the perfect definition of science as we can. That is why it has become the core of every other subject. Without using mathematics and statistics, you will not be able to push forward any of the books of knowledge that you already have. It does not matter in which subject you are, in which domain you are. As on today, you have to start applying data science and data science fundamentals in order to make some kind of a prediction or improve the field in any particular way. So now that you know what data science is, I would like to know what you feel data science is about. These are the student comments that I've had in the past few classes, past few batches. Is there anything else that you want to add? What you think data science is? What your expectation is out of this course? What do you plan on achieving by the end of this course? We are going to focus a lot on predictive modeling, as in being able to predict. Getting the underlying value is part of what is known as BI. Okay? Business intelligence. Chances are that a lot of you will be employed by business intelligence teams because that is where the next generation of data science ideas will come out. But your focus should be on understanding predictive modeling. So this entire course would be building up towards that. How to build predictive models. So when does business analytics become data science? Okay, so what really happened was predictive analytics, business intelligence, and all of these things are known as relatively structured data. When we say structured data, we're talking about this kind of stuff. You have rows and you have columns. This is what comes to mind when we talk about data, right? Whenever we talk about data, we are imagining an Excel sheet or a SQL database or something like that. We're not really thinking in terms of entire servers filled with images, texts, tweets, metadata, web log information, extremely messy looking data in audio and text, entire dumps of textbooks with absolutely no classification whatsoever. All of these things are also data. And in fact, this part of your data is 90% of all of the data. Your structured data is extremely small. Data does not really exist in your rows and columns format. So chances are that if you do get a job in data science tomorrow, your job would be somewhere over here. There is a very high chance. And that is where the exciting work is also happening. Okay. So when did business analytics become data science? It also happened because your data was getting more and more complex. It would not just fit in an Excel sheet. It would not be analyzed using your traditional forms of analysis. You can just sit down and identify your averages, means and medians, standard deviations, those kind of things. There was an explosion of computing power. Okay? It is not that the things that we are using for application in data science were not available before the 2000s. They were available, just that we did not have sufficient computing power to actually make them work. The moment we had all of our mobile phones and all of our data centers and all of these things, everything networked, everything moving at very high speeds, your simple analytics was no more sufficient. It had to become data science. Your storage options significantly went down in price, which means data is not being deleted anymore. In fact, there are regulatory requirements to make sure that the data stays. Governments want you to store your data. You can't just delete a lot of consumer information. Okay, so there are regulatory requirements also. People are storing all of that data. Nothing is going anywhere. Nothing is getting deleted. All of this is getting analyzed, and that is what is showing the improvement in the intelligence part. Then there was a complete shift in consumer / enterprise behavior. So imagine this thing: if you are a gamer in the 2000s, you probably were playing at home, right? You had your own single console and you were playing it on your TV. Nobody else was connected to it. But as on today, almost all gaming happens online, and most of the gaming actually happens on your mobile. And all of those metrics are being collected by your servers. They are seeing what kind of ads have to be sent to you, what kind of other games that you might be interested in. In fact, there is a good chance that some of you may have gotten this ad of data science based on what you were browsing online. Okay, even without you knowing, it might have happened, because that is where your interests were lying, and it kind of just went over. And also the methods to predict structured data and creating artificial intelligence are converged. So this is where the main question kind of comes in. Why are we doing all of this? What is the need for all of this? Okay, so a lot of the things that are necessary to run a business were already existing in predictive analytics. People were running businesses for hundreds of years without having all of these things. What is the need for all of this? It just so happens that we are all going towards creating an AI. We're all working towards creating an artificial intelligence, a truly artificial intelligence which can think like a human. And it can leverage the entire extent of the data that is available on the internet. So basically, an intelligence, a human type intelligence, which can leverage all of the information that is available. It is going to be networked. All the humans will be networked. Okay, our thoughts will be networked. That is the final aim. It may happen in 50 years, it may happen in 100 years, but the final aim is that. What after that, we don't know. But currently, everything that we're doing is about building artificial intelligence, understanding images, understanding text, understanding language. These are your biggest projects that are available in data science today. Okay, image recognition. The moment your photo comes up anywhere, it is already tagged by a particular bot, right? That is because it is able to pick up your image out of millions of images and is able to tag it directly to you. So computers are able to recognize faces. As you might see later on, that it is not a very easy thing for a computer to recognize a face or tell the difference between a dog or a cat. It has to be trained for it. So what we take for granted a lot of things, such as listening to a sound and knowing exactly where it is coming from, listening to a noise and understanding what exactly could have happened, those are difficult things for a computer to do even today. However, we are understanding how our own mind works, and we're trying to model all of that into creating an artificial intelligence. So how do we break down artificial intelligence to what we are going to study? There are two major topics. One is called as natural language processing. So natural language processing, NLP, and you have something known as deep learning. At one point, we don't really know how our minds work. So we're just throwing as much information as possible and we're expecting the computers to learn by themselves. That is known as deep learning. This is especially true for understanding images, understanding various structures within an image. Okay, so if you want to create security systems, identify only people who are coming into the building and not going out, you need some kind of an AI. If you have to build something like Alexa or OK Google, you need AI. That is your natural language processing. You need the computer to be able to process natural language. Okay, so these are the fields that we would be working on. There will be a lot of drag before we get to these points. There will be a lot of tiny things that you have to learn and can be pretty boring, but Once you have learned all of those things, the applications that you can build up are going to be extremely amazing. They would be really, really cool. So that is why data science is not born, it is evolving. We have been kind of working towards it for hundreds of years, probably. We don't know. We're just seeing that the evolution is extremely fast right now, and it is changing extremely fast. That is the only difference. People have even in the, for example, in 1956, what happened was General Motors, right? General Motors wanted to move some of their operations somewhere, and they realized that their entire operations data was all over the place, and there was no way of getting simplest answers for the simplest of the questions. Things like how many factories do I have? Nobody really knew, because General Motors suddenly became a big company out of nowhere. Nobody, not even the CEOs, knew about how many factories were there, how many vendors were there, how many manufacturing plants there were, how many people were working, how much goes off in salaries. None of these things. So in fact, they started this massive project of curating and putting all of the information in one place. So these kind of operations have been running for a very long time. Just that all of it is getting extremely structured. Everything is being discussed. Any new innovation that you do in terms of organizing your data will be immediately copied and standardized across the industry. All of these things are happening. All right. So having said all of these things, a little bit about me. I have actually I have 16 years of work experience now. I just finished my first June 2nd was the day I started work, 2006. All right, so it is about 15 years, 16 years, 2005 actually. So about 16 years of experience in various roles in the industry. I started my career in advertising. Then I went to marketing research. That's where I started learning statistics. Then I was into a lot of marketing analytics. I worked with Genpact and IBM for their marketing divisions. Then I moved to HP where I started working on proper data science, predictive analytics, teaching of predictive analytics, L&D. So this has been my work for a very long time. I've been teaching business intelligence, things like Excel and Power BI, Tableau, data visualization. Okay, and I have consulted on dashboarding, forecasting, and those kind of things. And I also worked on creating predictive models for several projects. Okay. So I have worked mostly in content development and training on a lot of things such as data science, big data, data engineering, everything that is application of your big data Hadoop on your applications, AI and machine learning. So these areas I have created a lot of content. I have taught a lot of classes. And then my areas of interest are currently natural language processing, AI frameworks such as TensorFlow and Keras. I love whatever is Python doing in terms of machine learning. Machine learning has become extremely easy when it comes to Python. Okay, so the only thing that you need to do is understand how Python is structured. You don't even need to become an expert in Python because a lot of libraries are doing the work for you. Everything is codified, everything is standardized, everything is optimized. Okay, Python has kind of contributed significantly towards the improvement of machine learning. And also Apache Hadoop frameworks for Apache Spark for ML. So Apache Spark can apply your machine learning models at an extremely large scale. And that has made the scaling of your models extremely easy. Okay. So most of the times what happens is we build our models for a small data set, let's say 3,000, 4,000 rows or columns. But your actual data set is in billions of rows. There is a scalability issue. And Apache Spark kind of solves that issue. Okay. So those are my areas of interest. So I will just tell you what my expectations are from you. I need to have a strong mathematical quantitative bent of mind. Okay, I am not expecting you to be experts in mathematics, but I want you to have a quantitative bent of mind, as in being open to analyzing numbers. You should not be scared of looking at big sets of data or understanding mathematical terminology, metrics, and those kind of things. Some amount of experience with Excel and DDW and cubes, that is good. Even if it is not there, it is fine. I'm going to explain all of those things as and when team goes on. Some basic programming skills are kind of expected, or else because we would be starting off, even though we would be starting off with the fundamentals of Python, having some programming skills, including SQL, is a good place to be when you are actually applying for a job. So in the next 6 months, let's try to pick up your programming skills as much as possible. And you also need to have a good understanding of your business needs. Okay, so you need to understand what your business is. So for example, if you're working with an IT firm, you need to understand whether they're in the services or whether they sell products. What kind of products are there? Who are the competitors? What is your go-to-market strategy? You should have answers to all of these things. What is their market share? Okay, what is their next strategy to break into the market? All of those things are kind of necessary. You need to really understand your business. Without that, you will not be able to do much, even with the skills you have at hand. So start understanding more about your business, talk to your business leaders, attend the various calls that keep happening within your organization, understand what various functions are, what various initiatives are coming up, see if you can join any of those things. Okay, that is kind of necessary. Okay, so these are all the things that are covered in data science. We'll go through these things. So here are the ideal student expectations. Please understand that you will learn the basics of statistics and get a statistical mindset, statistical thinking mindset. But practice and further reading is required. You will not become an expert on statistics, but you will have a good understanding of what statistics is doing as far as data science is concerned. You will learn several algorithms, but they are not exhaustive. We will be covering about 8 to 10 algorithms. They are not the final number. There are more algorithms out there. Please understand that. However, these are the algorithms that will set up your expectation, and they will set up your understanding and how to approach a supervised learning model versus unsupervised learning model, those kind of things. If you have that understanding, you can always pick up a new algorithm. There are thousands of algorithms. No one person can cover all of them. And sometimes you might be writing your own algorithm. So you need to know how to do that. You will learn some programming languages and implement machine learning in it, but this is not a programming class. Okay, so programming by itself is a vast subject. We are not dealing programming here. We are only talking about implementation of machine learning using Python. And as I said, the aim is you will be able to crack interviews and get job offers. But how good you are at the job depends upon you. You will have to kind of start, you're starting at scratch, so you will have to kind of work your way through it. Also, you should be able to learn enough skills to pick up projects in any field that you're passionate about, but you must be passionate about something. Please understand that. Identify something that you really want to work in. That way, you will be able to deliver more. If you are into gaming, pick up gaming. If you are interested in healthcare, pick up healthcare. See how these things that you're learning are applicable in healthcare or in gaming. Okay, and understand one thing, this is not the last time that you will be upskilling yourself. Upskilling will continue. Even when you join a job, there will be trainings, constant trainings. You will have to read up. You'll have to see what is happening. Okay, and then a couple of things. Take an hour to revise the class every single day. Main thing I always tell my students is, if you have heard something in the class, it is going to go away in the next 24 hours. If you do not revise it, that information would be lost. So clear your calendar right away. Every day, within 1 hour, finish all of the revision. If there is any task, finish that task. Don't keep anything during that time. Do not procrastinate. Please do not procrastinate, because 1 week down the line, you will have to do 7 days worth of work, which you will never do. If not 1 hour, put half an hour to revise, and do it within the 24 hours before the next class starts. That is absolutely necessary, because after 24 hours, all of that information is gone from your brain. I can guarantee you that. Finish the exercise as soon as the topic is covered. Some of them can actually take time. Programming exercise especially can take time. Okay, and then your programming exercises have to be done enough number of times till you kind of memorize them, but don't sit and mug them up. When you keep writing them, try to get them from your memory, start writing them, see if you can tweak them around and those kind of things. That way, memorize them, but do not actively, mug them up. Then start working on a cheat sheet. So the idea is the 6 months of course that we do, at the end of it, all of it should be in one sheet of paper. You should be able to revise everything within about 20 minutes. If somebody says there is an interview in half an hour, you should be ready. Create that cheat sheet. Start from day one. And also talk to people in your organization, find out what kind of application of data science is happening. You need to know real life use cases of what is happening in data science. While things can be very fantastic in class, in real world, they are very, very mundane. Understand the difference. Then keep the amount of work done in a day manageable. Do not procrastinate. If you have, that is why I'm saying if you are going to revise the class on the same day, your work would be manageable. You will not have 7 days or 10 days of work piled up. If you do that, again, this is also a habit that will go on for future. Whatever work you have on that day, finish that day before you go to sleep. All right, please do not procrastinate these things. Finish the revision within 24 hours. I cannot emphasize on that. And also start working on your presentation skills. Even if you are really good at presentation, everybody can improve. Please do that. And also, here are some of the resources that I want you to start putting up on your favorite tab. Kaggle, KD Nuggets, Stack Overflow, pythonprogramming.net. And if you find any new sources, please share them with me. Okay, keep your Python and R console on at all times. There are many libraries that you need to know. There is a lot of there is a lot of stuff that you need to kind of remember in Python. Okay, so there are libraries that you need to remember. There are names of functions that you need to remember. So keep the R and Python console all on at all times. I will show you how to access the various functions within a particular class. Go through them, see what they can do, what are all the various arguments and all of those things. And then practice, practice, practice. Please understand, within 2 years, if you start today, there is nothing you cannot learn within 2 years. You can learn boxing within 2 years. You can become a reasonable boxer within 2 years if you actually put in the work. You can become a decent musician. And when I say decent, I am saying semi-professional. You can become a semi-professional musician, sportsman. You can learn an entire language. You can start today and you can actually learn Japanese and have a conversation with a Japanese person if you work for 2 years. 2 years is a long time if you put in that 1 hour, 2 hours of practice every single day. So data science, especially data science, because the way we teach data science is very, very standardized. Language, boxing, and music might be different, but data science instructions are very standardized. Irrespective of wherever you go, the quality of the quality of instruction is more or less going to be the same. It all depends upon your work. Okay, so even the data sets that we use, the kind of programs that we use, the examples we use are more or less the same everywhere, because those are the ones that we have identified as the best way to teach you. 2 years is a long time to become a very good data scientist in general. So use that time and kind of work with it. Okay.
Thank you.